Hey everyone. So in this video, we're going to wrap up topic 1.7, summary statistics for a quantitative variable. We've already addressed the first two learning objectives in previous videos. So in this one, we're going to explain the selection of a particular measure of center and or variability for describing a set of quantitative data. So let's talk about outliers. In previous videos, we, again, just kind of eyeballed outliers. If points seem to be unusually low or unusually high, we would just say, that's a possible potential outlier. But in this video, we're going to define two methods or two rules for determining whether a value is an outlier. The first of these methods uses the IQR. And so it says that a value is an outlier if it's greater than 1.5 IQR above the third quartile or more than 1.5 IQR below the first quartile. So let's go ahead and use an example here to illustrate how we would use that definition. All right, so we have a dot plot, which is showing the number of pages in Mrs. Molesky's favorite books. And we can see that, most of the data is, around the 320 to 340 page interval. But we've got some values on the low side and a couple values here on the high side. We would like to know if any of those are outliers based on the IQR definition. We've got some summary statistics down here on the bottom. What we need also, though, is the IQR. So let's include that here. Remember, the IQR is the difference between the first and third quartile. So 344 minus 314 is an interquartile range of 30. Okay. So let's start at the third quartile location and then go 1.5 IQR above it. So we're just going to add 1.5 IQR. Okay. So we go ahead and substitute those values and we get a result of 389. Okay. So think of this 389 as the cutoff, right? Anything above 389 is going to be a high outlier. Well, when we look at this dot plot, we see that it goes 340, 360. So this would be 380, right? So there's definitely nothing bigger than 389. So these two high points aren't actually outliers at all. All right, let's check for low outliers. So for this, we're gonna start at the first quartile location and then go 1.5 IQR below. So that means we need to subtract that amount. All right, so we substitute the values and we get a cutoff of 299. Okay. So anything that's 299 or less is considered a low outlier. So we can actually highlight that in the dot plot. So start at 299 and go to the left. And so we can see that those 3 points would be considered low outliers, okay, based on this definition. All right, we have a second definition for identifying outliers, and this one is based on the standard deviation. So this says that a value is an outlier if it's 2 or more standard deviations above or below the mean. So we'll go ahead and use the same data set, right, the number of pages in Mrs. Molesky's favorite books. And then we will take the mean and go 2 standard deviations above. So we're going to add 2 standard deviations to the mean. Substitute the values and we get a result of 419. Okay, and so once again, our dot plot, the scale only goes to about 360, 380. So there's no way that any value is above 419. All right, let's go 2 standard deviations below the mean. Right, so that's mean minus 2 SD. All right, after substitution, we get a cutoff value of 213. So we can identify that number on the number line and just kind of highlight or shade everything lower than that. And that identifies just that 1 point as an outlier. Okay. So the two methods give different results. This one is a little bit more conservative, I guess. It doesn't identify as many outliers. Where the other method is more aggressive, right? The IQR method seems to identify more outliers. Traditionally, we've used the IQR method for identifying outliers. So between the two, right, if you have to choose one of these methods to use for finding outliers, I would recommend using the IQR method. All right, so now let's talk about how outliers, their presence or their absence, influences some of our statistics. So here we have a dot plot of the original data set with that low outlier included, and then a second dot plot where we've removed the smallest value. And then we have some of the summary statistics down on the bottom. Right now I want to focus on measures of center. Okay, so that's going to be our mean and median. All right, so I've color coded these, red for the mean and green for the median, because I want to point out that there's a big discrepancy or a big difference in the values of the means, both with and without the outlier. The median, not so much of a difference. They're almost the same, right? Difference of 1, and here the mean is a difference of 10. So what that means is including that low outlier has an effect of dropping the mean by 10 whole pages, right? Which is, it's noticeable. Whereas that same outlier only has the effect of dropping the median by 1 page. All right, so let's think about why this is, right? Why is the mean more influenced by an outlier than the median? Well, let's think about how we calculate the mean. The mean is averaging all the values together. So if you have an extremely low value, that's going to be included in the average. The median doesn't average, right? The median just kind of ignores everything except the 1 or 2 points in the middle. So this value could be 0, right? It could be negative 1,000, which of course doesn't make sense in this context, but the median wouldn't care how low the minimum is because it doesn't even look at it. It just looks at the 1 or 2 values in the middle. All right, now let's look at measures of variability or measures of spread. Okay, so standard deviation, IQR, and range are all measures of variability. Okay. So I've color-coded standard deviation and range in red because as you can see, they change quite a bit when we include or remove an outlier, right? 51 versus 33, 204 versus 132. The IQR I colored green because it doesn't really change a whole lot. It's only a difference of 4 here. So again, let's think about why the standard deviation is so big, so much bigger when the outlier is there. Right? 51 is almost 20 units, 20 pages more than 33. So the standard deviation, remember, is measuring the average distance from the mean. So if I have a point that's far away, it's going to have a really far distance between it and the mean. And that far distance, that big distance, gets averaged with all the other distances. And so that's why the standard deviation is much larger when we have a point very far away from the mean. Okay. The range, well, this one's probably makes more sense. The range is just based on the minimum and the maximum, right? So the farther apart you move the minimum and the maximum, the greater the range will be. Okay. So when you have an outlier, that means that there's a very big distance between the min and max. Okay. Now, how about the IQR? Why is it hardly ever changing? Okay. Well, remember the IQR ignores the lowest 25% of the data and the highest 25% of the data and just focuses on the middle 50%. Okay, so it doesn't matter what values are in the lowest group or quarter or what values are in the highest group or quarter. All that matters for the IQR are the values in the middle 2 groups, that middle 50%. And we'll never see outliers in those 2 groups. All right, so in summary, which statistics should you use, right? We've talked about a lot, mean, median as measures of center, and then IQR and standard deviation, as well as range for measures of variability. So for distributions without outliers, the mean and standard deviation can be used, right? We know that there won't be any outliers that are going to drastically influence or change those statistics. But when there are outliers present, we should use the median and IQR, right? Because we know that these are very resistant or will hardly change when an outlier is present or not. Okay, so these, we call them robust statistics, which means that they kind of preserve their value whether or not there's an outlier.